fireball after fireball. What Elon Musk is doing may sound crazy. But crazy is the new norm. In today's video, we'll break down the vision behind inventions that SpaceX is creating. From the recent test flights that ended up exploding, to Starlink's current status, and a look on Crew Dragon's test flight and equipment. So watch to the end and make sure to subscribe for more amazing videos. As usual, all the links to the sources are given in the description box. Let's go. First, let's get you an overview of what's going on with SpaceX. The goal of SpaceX is to land the first humans on Mars by 2024. Mars is, at its closest, 55 million miles away. So, to get there, SpaceX needs to make better rockets than humans have ever made before. The first rocket SpaceX ever made was the Falcon 1. Named after the Millennium Falcon of Star Wars. In total there were 5 launches, in which 3 of them failed and 2 succeeded. The cost per launch was $6.7 million. After that, came the first version of the Falcon 9. The Falcon 9 was 48 meters tall. The rocket was also a lot stronger, with over 10x more thrust power in the first stage. In total there were 5 launches. The cost was between $54 and $60 million per launch. SpaceX is currently developing an even bigger and better rocket. The Starship. Also known as the Big F rocket, and for a good reason. The rocket stands 118 meters tall. It is estimated that the Starship can carry a payload of 100,000 kilograms to low Earth orbit, making it by far the most powerful rocket that has ever been built. The Starship will be a fully reusable transportation system designed to carry both crew and cargo to Earth orbit, the Moon and Mars. SpaceX has an ambitious mission for Starship to build a sustainable Mars colony before the year 2050. Now, let's dive deeper into the launch and crash of the Starship. What happened? To start things off, let's look at Starship prototypes that we've seen fly so far. Starting with Starhopper in 2019. Starhopper has undergone a series of very brief hop tests. They're meant to collect data and help engineers hash out how they'll land a spacecraft on another planet. Then they launched SN5 in 2020. SN5 completed a 150-meter hop on August 4, 2020, descending to a nearby landing pad. This marked the first successful launch and landing of a prototype with full-height propellant tanks. SN6 performed the same flight test plan just 1 month later. Let's just note that serial number 5, 6 and Starhopper all landed at about 1 minute into their flight. So, SpaceX began their in-flight testing of Starship hardware with basically cylinders that had a single Raptor engine on the bottom. Serial number 8, at the end of 2020, took off with 3 Raptor engines, and was equipped with aero surfaces so that it would have a controlled descent and was planned to have a very nice and soft landing, like a cat. However, that's not exactly how it all went down. Despite some failures in the engines, the serial number 8 kept on accelerating and reached to its apogee, which is about 8 miles, or 12.5 kilometers in altitude. As the Starship passes through this cloud, it gets ready for its final maneuver, where it'll kick itself around and try to land gracefully like a cat. You can see the engines gimbaling and getting ready to fire up, and 2 of them fire up as planned, but because of the low pressure from the header tanks, there wasn't enough propellant feeding into those engines, and one kicks off, and the other starts burning itself and spitting out green exhaust, and the Starship touches the ground at a velocity higher than 0. So, in conclusion, almost all objectives were completed and executed gracefully and beautifully, except for the velocity at landing. Now, let's look at Starship SN9. SpaceX did their second high-altitude test flight for Starship. It had been ready to go after SN8 crashed, but had been held up by a combination of SpaceX's lean development process, engine problems, and the FAA approvals. By now you've probably heard, the landing didn't go as planned. This is what happened. The vehicle was in the horizontal descent orientation. It tried to light 2 engines to perform the landing burn. But only one lit, it lost control, and ended up crashing at about 200 kilometers per hour. So, what do you think? Are these promising projects? Before I get into the next part, if this video does well, let's say, 100 likes, then I will happily make a part 2, and talk about the comments that you leave, and the SpaceX's next projects. Let's go back to the Falcon 9 rockets. This rocket is responsible for delivering Starlink satellites to orbit. To date, SpaceX has launched roughly 650 Starlink satellites to orbit. As a reminder, Starlink is a constellation of satellites that can provide high-speed, low-latency internet, all over the globe, particularly in remote or rural areas, where connectivity is limited or completely unavailable. However, SpaceX only needs 24 launches for global coverage. Given SpaceX's current Starlink production and launch rate, Starlink will have global coverage, excluding the poles, by the middle of 2021. Once Starlink is complete, the venture is expected to profit $30 to $50 billion annually. This profit will largely finance SpaceX's ambitious Starship program, as well as Mars Base Alpha. What you are watching is the Falcon 9 Block 5. The Falcon 9 Block 5 is SpaceX's partially reusable, two-stage, medium-lift launch vehicle. Block 5 is the final iteration of the Falcon 9. The goal is to apply all the lessons learned from 56 previous Falcon 9 pre-Block 5 flights into a human-rated reusable rocket. The Falcon 9 contains three main components: a reusable first stage, an expendable second stage, and a reusable fairing. On March 2, 2019, Falcon 9 launched Crew Dragon on its first demonstration mission, and the next day it became the first American spacecraft to autonomously dock with the International Space Station. After its stay at the space station, the spacecraft successfully splashed down in the Atlantic Ocean, completing its mission and demonstrating SpaceX's capabilities to safely and reliably fly astronauts to and from the space station as part of NASA's Commercial Crew program. The Dragon spacecraft is capable of carrying up to 7 passengers to and from Earth orbit and beyond. It is the only spacecraft currently flying that is capable of returning significant amounts of cargo to Earth, and is the first private spacecraft to take humans to the space station. SpaceX is using the Falcon 9 Block 5 launch vehicle to launch Dragon 2. Aside from the vehicles, designing the suits are an essential part of the journey. One of the things that was important in the development of the suit was to make it easy to use. Something that the crew just has to literally plug in when they sit down, and then the suit takes care of itself from there. The suit is part of the Dragon system. So it is kind of a suit seat system. The seat that the crew is in and the suit are in a lot of ways working together. It made sense that they designed Dragon in-house to also design the suit. When the crew gets in the capsule, they get in their seats and they plug the suit into the umbilical that's attached to the seats, and the umbilical is providing everything that the suit needs. It provides the avionics or electronics for communications, and is providing the air to cool the suit, and then it also provides gas when needed to pressurize the suit. So it's really a single point that lets the suit do all the things that it needs to do. I think one of the things that's cool about the suit is it's not just a piece of hardware or a suit, it's a very personal thing to work on, and so it's a really amazing thing. Well, that's it for this video. I hope you enjoyed and learned something new. Make sure to subscribe and turn on the notification bell for more amazing videos like this. We'll see you soon.